In our last video, we explored the basics of Excel, the user interface, data types, and how to clean and format a simple data set. But now it's time to unlock the real power of Excel, formulas. Excel isn't just a notebook for numbers, nor even a fancy calculator. It's a full-blown computational platform. When we set up formulas, we can use Excel to create complex chain reactions of data transformation, which are all dynamically recalculated whenever there are any changes to our input. In this video, we'll look at how to write Excel formulas, how to reference cells, ranges, and other worksheets, and we'll take a tour of some of the commonly used functions that are built into Excel. Let's start with a few simple examples. Just like in the interactive Python prompt, you can write expressions directly into a cell, and the result is displayed. Now in Excel, every formula begins with an equal sign. So for example, equals 3 returns the number 3, or equals 1 plus 1 returns the number 2. If we omit the equal sign, what we get is not a formula. Excel just stores the text 1 plus 1. Similarly, if we include a quote in front of the equal sign, again, just the text is stored and the formula is not computed. Now Excel formulas respect precedence rules, or BEDMAS. So for example, 3 minus 2 times 5 returns -7 instead of 5, meaning it does the multiplication first. We also have the option to do comparisons in Excel, such as 1 is less than 2, which is true, or 1 equals 1. For equality, Excel uses the equal sign and not the double equals as in Python. This is the comparison between the number 1 and the number 1, and that returns true because they're the same number. If we want to do not equals, we can use this odd diamond shape, and this says 1 does not equal 2. It might help to remember the symbol as being both a greater than and a less than sign, but not an equals. Looking at our workbook with these basic examples typed in, we see the results of various formulas and not the formulas themselves. To see and or edit the formulas, you can select a cell and either use the formula bar or hit F2 to edit in place. To see all of the formulas on your entire workbook at once, you can hit Control and the backtick key, which is the top left corner of most keyboards underneath the tilde. Next, let's look at a more practical example. So here's our starting data. We have a simple budget tracking sheet that has various income and expense categories broken down by month. This is just static text and numbers for now, no formulas yet, and you can download this sheet from the course notes page. So let's start by calculating the total monthly income for just January. So down at the bottom here, in the cell next to the title Total Income, we could type in a formula that sums each of the numbers from our incomes for January. You might be tempted to just start typing the numbers, so equals 800 plus 1525 plus 200 plus 3000. And Excel will happily add those numbers for us and display the result. But this would be a mistake. If we write our summation like this, then our formula is hard-coded, which means that if any of the expense amounts change, the formula won't be updated for us. We'd have to change both the expense amount and then rewrite the formula manually, which is an error-prone and unnecessary way to do things. Instead, it's better to use cell references. So we could say equals B2 plus B3 plus B4 plus B5. Now, instead of typing the values directly, we're telling Excel to use the contents of these other cells. When we hit enter, we get the sum, and if we change anything, then our sum is updated automatically. This is already a much better approach. However, we're still typing out every addition manually. With Excel, we can do better. A more coherent approach is to use Excel functions. Functions in Excel are like pre-built formulas. So let's replace our previous sum formula here with a function. Like functions in Python, functions in Excel denote a process of going from inputs to outputs. The sum function does what you'd expect a sum function to do. It takes in a bunch of numbers and returns their sum. Functions in Excel have pretty much the same syntax as functions in Python as well. We use the name of the function and then round brackets with a list of arguments. Both function names and cell references in Excel are case insensitive, so we could write this same formula in all caps if we wanted. And this gives us the same answer, but there's an even more succinct and clean way to write this formula though. Here we listed every individual item that we wanted to sum. But imagine if you had 100 numbers. It would take a while to write out each individual reference. Instead, Excel lets us refer to ranges of cells, and most Excel functions understand how to parse these ranges. So we could replace this formula with a more natural expression like equals sum from B2 to B5. This says again the same thing, sum all the cells between B2 and B5 inclusive, and notice the result is no different. It's just a simpler way to express the same thing. We can quickly and easily sum our expense categories the same way, so we could say equals sum from B8 to B16. and then we can easily see how much we have left over if we calculate our net savings as the difference between those two values. So equals our total income minus our total expenses, and we're left with the difference. Another important feature is how formulas behave when you copy them. So let's try copying our January totals and pasting that into the February column, for example. If we double-click this cell, or if we hit F2, we can see that Excel has automatically adjusted the formula for us, changing the range that's highlighted and shifting it into this new column along with our formula. This is called a relative reference. Excel will automatically adjust formulas relative to wherever they've been pasted. This is usually very helpful, but it can also make mistakes, as we'll see in a moment. So it's always a good idea to check that your outputs are what you might expect, and that the correct input cells are highlighted when you click on your formula. Next, let's add the yearly totals for each income and expense category. So in the column to the right of our December data, we'll add a total column. Now ranges can work either horizontally, vertically, or both. In our previous example, since we went from B something to B something, we only changed the row number. This means we're referencing a vertical column, or part of one. If instead we keep the number the same and change the letters, we can reference a horizontal range. So for example, we can get a yearly total per expense category by putting sums at the end of each row. Notice that in this range, the letters are different, but the numbers are the same, and so the range is referring to a row or a section of a row. If both the letter and the number change, so for example, let's put this elsewhere, then we're referring to a rectangular range. These are less practical. Many Excel functions will only work with a one-dimensional range of values, but it's good to be aware that this is an option because you may find uses for this knowledge later on. For now, though, we don't need that. We can also calculate other values. For instance, it might be useful to know the average value of each expenditure or income category. So we can use the average function and then use that same range to average those values instead of sum them. Then we can drag these formulas down to cover all of the other categories if we want. So select both of them and take this little fill handle and drag it all the way down. When we dragged our formulas down to cover all of the rows, we got some zeros in the totals for our blank rows, and an odd div over 0 value in the average column. Now an average is calculated as a sum divided by a count, and since we have no values to average, it ends up being 0 divided by 0, which Excel can't compute. Fortunately, the solution here is to just delete those rows. But if you encounter a similar error in your sheets, you should look for where you have a division operation and find out why your denominator may be 0. Another error you might see somewhat often is a missing reference error. Let me just cause one deliberately here. So for example, if we put a formula that references another cell like B2 plus 1, and then delete the cell that it was referencing, not just the value, but the entire cell. So if, for example, I said delete this whole column, notice that our equation has changed from a number to #ref. This is an error signal that means the formula points to a cell which no longer exists. Note that it's not just that the cell is empty, but that the cell itself was obliterated. Excel can't find it anymore. It's a bit of an oddity when this may or may not appear. You might think that since the old contents of C2 have just shifted over, that there's still a B2, so our formula should still work pointing at the new values in B2. But Excel tries to update all of the sheet to accommodate changes like this. So formulas that used to reference C2 are now referencing B2. So what should our old B2 references be changed to? There's no good answer to that, so Excel just gives us an error. All right, so undo to get our data back. And now this can also happen when cutting and pasting, though oddly, not when copying and pasting, just cutting and pasting. It's a bit of a subtle nuance in how Excel is handling memory addresses in the background, stuff we don't usually need to be aware of, but we do need to be aware of the consequences, so watch this. I'll take any other cell, I will cut and paste onto B2. If I cut and paste any new cell on top of B2, our formula referencing B2 gets disrupted. If I undo that and try with a copy paste though, no problem. Copy and paste, no problems. I don't have a simple explanation for why Excel does this, but one way to think about it is you can think when copying, Excel will copy the contents of a cell, whereas when cutting, Excel will move the cell itself. This is a problem akin to the aliasing issue we saw in Python, though in this case it's built right into how Excel operates. I don't have a solution here, but I wanted to make you aware of the issue so you can be careful when working on complex workbooks. There's a certain sort of existential dread that comes from making a small change to a very complex workbook and having random errors pop up because some hidden background Excel rules got in the way. So hopefully now we can avoid that fate. I'm going to undo all of these changes now so we have our original working budget back, but if you ever encounter these errors in your work, now you'll have some idea of how to deal with them. Oh, still want that. All right, now back to our budget. So let's complete all of our monthly totals by doing the same dragging that we did for all of our category totals. So we just drag it across and verify for each one of them that we're using the right values. There we go. And now to create the grand totals, that is to say the total yearly expenses and the total yearly income, as well as our total net savings, we can actually just take this formula and drag it one more step forwards. So this is going to add up all of our categories in both sections. So that's all of our total expenses, all of our total incomes, and the overall total difference. And we can see for the entire year, our budget was nearly balanced, but we ended up $100 in the hole. This isn't ideal, so let's see if we can adjust our budget to balance these books. Perhaps we can take on a few extra hours at work to increase our job income, maybe trim entertainment or miscellaneous spending a little. When we make changes to our workbook, we can see the entire workbook updating dynamically in real time. So if I take on a few more hours at work, maybe let's say make another $50 in April. So instead of 800, it's now 850. And then we can see our total deficit is updated as soon as we hit enter. This is why active workbooks are so popular. You can build the design of your computation once, and then the sheet reacts automatically to any changes in the data. We could take this budget, copy its file, and use it again next year without having to type any new formulas. Next, let's add some formulas to help us see more clearly what our biggest incomes and expenses are. In the column beside averages here, we have a column marked % of total. And this column will display a calculation of what percentage of our total income or total expense this specific item contributes. So for that first row, that would be the yearly sum of our part-time job divided by the total income for the year. So we get our job income as a proportion of our total income. So that would be equals N2 over N18. And this gives us a number between 0 and 1 representing the percentage of our yearly income that came from our part-time job. We can then try to copy this into the other income rows. But the result looks incorrect. We have a percentage that's over 1, which that's not right, and we have a number that's div by 0, which definitely is an error. If we click on these cells, we might be able to get a clearer picture. So the first one is the one that we typed in. That works fine. The next one is taking the next value, but it's dividing it by the expenses instead of our incomes. We're still doing incomes here. The next one takes the next value, but is dividing it by the net savings, and the next one after that is taking the right value, but again, dividing it by a value that doesn't even exist, giving us div by 0. So what's happening here is that Excel is updating our formula as we dragged it into new cells, which is kind of what we wanted. We need to divide the total for each different row, but we wanted each of them divided by the same grand total amount. That is, we wanted N2 over N18, and then N3 over N18, and then N4 over N18, and so on. Instead, Excel was updating both references. So we got N2 over N18, and then N3 over N19, and then N4 over N20, and so on. To fix this, we can use what are called absolute cell references, sometimes known as fixed references. Essentially, we can put a $ in our reference so that when it's dragged or copied into new cells, Excel knows not to change those values. For example, here we need the number part of N18 to stay fixed while we drag our formula downward. So we can change our initial formula from N2 over N18 to being N2 over N$18. And this tells Excel when dragging, do not update the 18 part. So N2 can still be changed, but not N18. And now we'll drag it. And if we copy this to the other cells, we see we can get something that looks more like a correct calculation. We can do a similar calculation for expenses, so equals N8 over $N19. Now you might be tempted to use a fixed reference like this, with the $ in front of the entire reference. This, however, is only telling Excel to keep the N part fixed, the column letter. The row reference, the 19, can still change. So if I hit enter with this fixed reference in place and drag, we end up with similar errors. If we want, we can fix both parts of a cell reference by putting two $, one in front of each part. In this specific example, it's unnecessary to lock the column since we're only dragging vertically, but it's not incorrect. And now with these equations, we can see the proportional contribution of each of our categories to our overall totals. If we format this column as a percentage, so Control-Shift-5, if we format this column as a percentage, our table looks a bit cleaner, and we can quickly verify that the different percentages sum to 100. All right, now our little demo workbook is pretty sufficient for tracking a yearly budget, but let's add a little bit more intelligence to it. Suppose you wanted to know if your variable expenses, like groceries, entertainment, transportation, and miscellaneous, are exceeding the income we're making from our part-time job specifically for each month. So as to say, is our part-time job covering all of our variable expenses? So down at the bottom of this sheet, we can add another kind of formula that enables us to use if statements in Excel. That's the if formula, and it has 3 parameters. A little tip here for Excel: if you start typing a formula and you open the bracket for the argument section, it will prompt you with a little tooltip explaining what needs to be put into that formula. So here we have 3 parameters: a logical test, a value if true, and a value if false. So the first argument to our formula needs to be some condition, so something that's either true or false, like a comparison. Then the second and third are the values that this formula will return if the condition is either true or false. Now, each of these arguments can be made up of nested calls to other functions or operations, so we can generate some complex logic if we wanted. So from our example, as our condition, we want to check if our variable expenses exceed our part-time job's income. So we could sum up our variable expenses by saying sum B13 to B16, just these 4 of our expenses. And we want to know, is that greater than or less than our part-time job for the month? So is that greater than B2? If that's true, I'll just say the word over. If it's false, I'll say the word under. Now the values for these results can be anything. They can also be other function calls if we wanted. I'm just using simple text here to demonstrate the if statement. So if the sum of the values from B13 to B16 is greater than B2, it's going to return the string over, else it will return under. If we drag this to the whole row, we can see our part-time job is covering our variable expenses consistently. So let's extend this a bit further. Let's say we wanted this label to only say under if our variable expenses are covered and our monthly budget has a surplus. So months with a negative balance should say over, as in we've overspent. We can accomplish this with more logical operators. In Python, we'd use words like ands and ors to combine conditions. In Excel, it's the same, except these operations are structured as functions. So to combine 2 conditions, we say or. Now the first condition is our original condition here, that comparison that our expenses exceed our income. And the second condition for our statement here was that we had a budget surplus, so that our income was greater than our expenses. So is B18 less than B19? In that case, our income is less than our expenses, so we've overspent in that month. And when we hit enter and drag it across for everyone, and now for months where there is a budget deficit, it tells us that we've overspent. You can extend if statements in Excel to make nested if statements by putting more calls to the if function inside its parameters. So instead of over or under as the results, we could put another if statement if we wanted to nest our conditions like that too. There are many more functions available in Excel, and a lesson explaining all of them would be a bit like a lecture where I read a dictionary to you. We will encounter more functions as we continue to explore Excel in future videos, but to get a sense of the number of functions, let's take a quick look at the Formulas tab in the ribbon menu. This tab organizes hundreds of functions that Excel knows how to use. They're grouped into categories, so you don't have to memorize everything, you just need to know where to look. Well, starting at the left, and we'll come back to that first button in a second, we have the AutoSum button, which is a shortcut for quickly adding things up. There's also options for averaging mins and maxes. There's a recently used category, which shows the last few functions that you've used in case you need them again, or just a bunch of random ones if you haven't used enough functions lately. There are financial functions for loans, interest rates, and financial calculations. There is the logical functions, which is things like if, and, or, and not, which help Excel make decisions. There are text functions for working with words and letters, like joining text together or changing the case of a word. There are date and time functions that handle dates and times for operations like finding the difference between 2 timestamps. There are lookup and reference functions for searching through large data sets automatically. There are math and trig functions for more specialized math operations beyond just adding and subtracting, and a whole category of extra menus. So a more functions button that has even more submenus of functions for statistics, engineering, and much more. Now you don't have to memorize any of this right now. The key thing is, if you need a function and you're not sure what it's called, this is a great place to start looking. You can also click the Insert Function button. It's the FX button at the top corner. And you can type keywords like average, to do a search through all the existing functions. It does a character match search for function names or their descriptions, which honestly isn't that great of a search. Sometimes Google or GPT will be much faster, but if you at least know how to browse through these categories, you can usually find what you're looking for. The Formula tab in the ribbon menu has additional operations for working with complicated Excel workbooks. There's an option for defining variable names, which can help you a lot in place of having to remember, did I put that value in cell Q37 or was it R14? Instead, you can put variable names and then reference those names in your formulas. There's also a button to toggle between displaying formulas or their results in the table, and if we press it, our table becomes a lot more literal and we can quickly scan across the cells to see the inputs for each formula as well. For our next trick, let's make a new worksheet in this workbook, a new tab. So click this little plus to create a new tab, and then we'll rename this one Savings. And in this new tab, we're going to make a simple interest calculator for savings and loans. To start off, we have 3 account types. Each one with their own interest rate. Now you can modify these accounts to fit your own reality later, but consider that we have 3 accounts, one basic savings account, another investment account like a mutual fund or an index fund, and a student loan. Now each of these accounts are going to grow over time with compounding interest. So our savings account will receive a 1% interest for the year, we'll guess our investments gain 5% over the year, and our student loan for now will be at 0% interest while we're still studying. Now we're going to track the value of these 3 accounts over time, so we'll need header rows for each month. If I just type Jan and Feb, I can use Excel's auto feature to complete the rest. So if we just highlight them both and then drag, Excel already knows a bunch of common sequences and patterns and will automatically complete them if we ask it to. For our savings account, we want the amount saved to equal the net difference from our budget sheet. So if we earned more than we spent, we're going to put it all into savings. For example, if we go back to our budget sheet, in February we saved $34. So let's put all of that into savings. To do this in our second sheet, we need to be able to reference information from our first sheet. So for January, for example, the savings would be equal to B20. But we can't just say B20 because Excel would look on the current sheet for B20 and just finds it empty. Instead, we need to use a cross-worksheet reference. So before we can say which cell, we first need to specify which worksheet, and we can do that with the following syntax. Since our other sheet is called budget, we can say budget, exclamation point, B20. And if we drag that across the row, then we get our net savings each month. Though right now, each month resets to 0 after the month is over, we should make it so that our savings amount is cumulative. That is, it goes up or down by the net savings each month and then carries through into the next month. So for the first month, let's be nice to ourselves and say we start with a savings of $1,000. So we have our net value from the budget sheet plus an extra $1,000 in our savings account. And then every subsequent month, we can just add the value from the previous month. So we have budget at C20 plus the value to the left of this, which is in C2 of the local sheet. And then we can drag this formula across the rest of the sheet, and now our values are cumulative. And now we just need to calculate the interest. Now this isn't meant to be a course on finance, but to compute interest on a loan, we can use the following formula. This says take the value from the last month, C2, and multiply it by 1 plus the monthly interest rate. So the 1 is so that we keep the original money, and the plus all this other stuff is to compute the tiny fraction of interest that's gained. So if 1% is the yearly amount of interest, so $1 for every 100 saved after a year's time, then the monthly interest rate is that amount divided by 12. So we're saying take the original and compute this extra interest that's added on, and add that to whatever money we saved in our budget from the last month. And if we drag it across the months, we see that our money really starts to grow. In fact, these numbers seem way too big. So something must be going wrong. Let's click on one of them and see what we get. If we highlight one of these larger numbers, we can see that it's not even using the right numbers at all. So it's supposed to be calculating the interest based on the interest rate, which is in B2, but we're highlighting L and M only, where M would be the value from the previous month, so we do want that. But there's no reason for the December calculation to be referencing October at all. So that points to what our error is here. we forgot to fix that reference. So when we drag this across, it moved with us. So this reference here, inside our formula, L2 over 12, that's supposed to be our yearly interest rate. But now it's pointing at October's savings for some reason. That wasn't supposed to move. That was supposed to stay anchored in B2. And in fact, it should be B2 for all of these. And it's moving along with our calculation. So let's go back to our first interest rate calculation here and fix that reference. So instead of being B2, we're going to say $B2. And if we drag that value, now our numbers seem a bit more reasonable. And we can format everything as currency to make it look a little bit cleaner. Now, we can do a similar sort of thing for investments. Let's say we have $100 a month, which is extra to our budget, I guess, that we want to invest. So in January, we put in $100. February, we still have that original plus interest plus another $100. So in January, we have $100. And then in February, we still have that original 100 plus interest plus another $100 that we're adding in. So equals C3 plus our interest, so times 1 plus our interest rate, which is in B3, so B3 with a fixed reference, divided by 12 because that's yearly, and we want the monthly interest rate. And we made 42 cents. But now we're going to add in another $100 as well, so plus 100 every month. And we drag that across, and our numbers get too big. So now we can see it all. And if we drag that across, we can see the interest growing at 5% plus a steady savings drip. And lastly, let's consider the student loan row here. This is to track our student loans as accruing debt. So each time we receive a loan disbursement as income in our budget, we'll make sure it's tracked here. Thankfully, student loans are interest-free while you're studying, so we'll put 0% as the interest rate for now. We'll do the full calculation though, so you can continue to use this same sheet design once your loans become repayable. So in our budget, we have row number 5 for student loans here. So at first we can just grab that amount. So equals budget, exclamation, B5 for the first one. And if we drag that across, we can see the months where our student loan disbursements come in. So 3,000 and 3,000. Now for February onward, we need to make this cumulative because this is going to keep track of our total debt. So in February, we would add in the previous month. So it's budget at C5 plus the value from January. So that's the local sheet at C4. But again, we also want to calculate interest on that. So we'll say C4 times, and then we'll use the whole calculation here, 1 plus $B4, that's our interest rate, over 12. Drag that for the full year, and now we can see it accumulates. So at a 0% interest, it's not moving at all, but as soon as we have another disbursement here in September, then it jumps up to 6,000. If we'd like to see what that looks like when our loan becomes repayable, we can change the interest rate. Let's say it's a 5% interest rate, then that value goes up over time. But we can set that back to 0 for now, because we're still studying. All right, and that's it for our introduction to functions in Excel. Hopefully you've learned something about calculations, references, and/or financial accountability. You're strongly encouraged to try out this budgeting sheet and adapt it to your own circumstances. If you don't already have a budgeting system in place, this could be the start of a lifelong structure. And if you already do, then hopefully you found some inspiration or validation here. Please review the steps of what we built here, don't forget to blink, and I'll be waiting in the next video.